All right, so question number one. A healthcare provider has prescribed lorazepam 4 milligrams IM in 6 divided doses. How much will the nurse give per dose? So I always like to start by breaking down these questions to figure out exactly what they're looking for, just because they can get pretty wordy and they are designed to sometimes be confusing. So what I basically do is I go through and figure out, all right, so we have an order, which is lorazepam 4 milligrams IM in 6 divided doses. This 6 divided doses means that we're going to take the full dose and divide it by 6 eventually. So I'm just keeping that in the back of my head so I remember to make sure that I actually check and get the right answer. How much will the nurse give per dose? So that's ultimately what we're being asked to figure out. And part of the nuance of that is with the how much will the nurse give per dose, are we figuring out milligrams, milliliters? What's it going to be? And all of that information requires us to get into this medication label and figure out exactly what's being given. So we have our lorazepam, which we can tell because our generic name is given right here. We know that we're giving lorazepam, which happens to be Ativan, which is a benzodiazepine. We're not going to get too deep in the weeds on that. But as it's an injection, based on the information that we're given, it's going to be given as a liquid. So we know that we're likely going to be giving a liquid, so we're going to be providing our answer as a volume. So as we dig deeper into this label, we can see our concentration, which is 4 milligrams per milliliter. Obviously, that's very important because we're going to need that in order to figure out how many milliliters to give to reach the required dose. Just digging through, we can see that they give the information related to how to administer it, the concentration of how it's made up, whatever else. But I think we have enough information to move forward and figure out the answer to the question. So first thing I like to do when I'm working through this information is start with what I am looking for, and that's going to be milliliters. We know that because we are looking for a volume, and we're given the concentration of 4 milligrams per milliliter. So that's going to be the beginning of our conversion. Ultimately, my goal is to convert what we're given to what we're looking for. And we're going to do that based on the medications in the order. So if we're looking for milliliters, we know that the dose is 4 milligrams, and we know that the concentration is 4 milligrams per milliliter. So we can start our conversion based on that concentration because we know we're looking for milliliters. Step one for any dimensional analysis problem is to have what you're looking for as the top of your first fraction. I know that can be confusing, so I'm going to show you. We know that we are looking for milliliters. So what we're going to be doing is setting up our conversion so we can cancel out things as we go. And what that will basically look like is we have our concentration, which is right here. And at the top, I know that there's going to be 1 milliliter for every 4 milligrams. And I know that because it is given to us in the problem. I am putting milliliters at the top because I know eventually I'm going to need to cancel that out. I mean, I'm not looking to cancel that out. I'm looking to cancel out the bottom, the milligrams, because we're looking for milliliters. We want our final answer to have this milliliters in it. So in order to cancel that out, we're going to set up another fraction. This is all multiplication. And if you've ever done like high school chemistry or like anything like that where you're converting, you've probably seen this before. So I don't want it to be too confusing for you. But now we have our order, and we know that in our order, which is up here, we have our lorazepam 4 milligrams IM. We have 4 milligrams. And then when we go and add that out, we know that because we have milligrams at the top and at the bottom over here, so we have milligrams here, we have milligrams here, these will cancel out. We're treating them just like variables. If you were doing basic algebra, we want to cancel out things that we don't need. And then multiply across, and divide. So we have 1 times 4, and then 4 times 1. So we get 4 milliliters over 1, or over 4, I mean. And because there's no unit here because we already canceled it out, we're just going to have 4 divided by 4, which is 1 milliliter. But is that the answer to the question? The answer is no, because we're being asked basically to divide that into 6 doses. How much are we going to give per dose? So we have our 1 milliliter that we're giving total, and now we need to divide that by 6. I'm going to take that over here. 1 milliliter divided by 6 doses. Sorry for my handwriting. I'm writing on a new tablet, and it's a little bit weird. But we get 1 over 6, which is 0.177, I think. Maybe. I need a calculator. But then we're just going to round to the nearest 100th place. Actually, no, it's 0.667. Yeah, that's right. So if we round, if we're dealing with any volumes lower than 1 milliliter, we're going to round to the nearest 100th place. If we're using volumes above 1 milliliter, we're going to round to the nearest 10th place. So the answer here will be, based on rounding, 0.17 milliliters per dose. Now we're going to ask ourselves, does that make sense? Again, we always want to make sure that our answers make sense. If you got like 1,700 milliliters per dose, would that make sense? And the answer is no, because 1,700 milliliters is almost a 2 liter of Coca-Cola. And if you're administering a 2 liter of anything, you really want to make sure that that makes sense. If we were to give someone 2 liters of Ativan, they would die immediately. So 0.17 milliliters per dose. That is 6 doses total, which would give us a total of 1 milliliter. So yes, this does make sense. We can move on with confidence.